All right, in this video, we're going to be going over the Module 6 study guide. So the first thing here when we're looking at question 1, okay, is I have two equations in standard form, meaning ax plus by equals c, okay? When I have two equations that's in standard form, the best way to solve is elimination, okay? So what I need to do is I need to find the same coefficient with opposite signs. So what I'm going to do is multiply this second equation by 2. And when I do that, 2 times 6x is 12x. Let me see if I can get this to write a little bit better. So 2 times 6x is 12x. 2 times negative 5 is negative 10y. And 2 times 2 is 4. Okay, I don't need to change the first equation at all. So I'm just going to rewrite it right below it. So I have negative 8x plus 10y is equal to 24. Because I have the same coefficient with opposite signs, see I have a negative and positive, now I can simply add the equations together, and what's going to happen is my y values, my y variable, will cancel out, will eliminate. So 12x minus 8x is 4x. Negative 10y plus 10y becomes 0, so it's eliminated. And 24 plus 4 is 28. Now I can divide by 4 and divide by 4, and I get x is equal to 7. Okay, now that I have my x value of 7, now I can go ahead and take that x value and plug it into my original equation. Okay, so negative 8 times 7 plus 10y is equal to 24. Well, negative 8 times 7 is a negative 56 plus 10y is equal to 24. Now I need to get all of my constants to one side, so I'm going to add 56 to both sides, and I get 10y is equal to 80. And then I have to divide by 10 and divide by 10, so y is equal to 8. So now I have my x and y value. So my solution is 7, 8. 7 being my x, 8 being my y. Okay. In the second question, question 2, all we really need to do is identify the point where they intersect, where both the red line and the blue line intersect. So if I'm looking at this point right here, I can label that point as 1, 2. Okay, this is my x-axis, this is my x value, this is my y-axis, this is my y value. So my solution is just 1, 2. They're expecting you to make a mistake and put it in the wrong order, so don't do that. Okay, in question 3, we need to write the two equations, or which two equations make up the system that is represented in the graph below. So first thing we're going to do is look at this red equation, this red line, and identify our y-intercept, which is 2, and then identify our slope. Well, if I use this point and this point to find my slope, I went down 1 and over 2. So that means that my slope is a negative 1 over 2. And so my equation is negative 1 over 2x plus 2, because the 2 is my y-intercept. All right, for my blue equation, for my blue line, my y-intercept, oops, that's way too thick. Let's just change the color of this one. My y-intercept is equal to 4. My slope if I use these 2 points, is a positive 2 over a positive 3, so 2/3. Y is equal to 2/3 x minus 4. Okay, they're expecting you to make a mistake. So make sure you can identify your slope. This is really a slope question. Okay, and our slope, remember, is our rise over our run. And rise is the y value, your up and down, and run is your x value, left to right. Okay, so don't flip your slope, otherwise you might get the question wrong. Okay, question 4, we need to solve the systems, and I recommend using substitution because y is equal to 2x minus 3. What I'm going to do is I'm going to substitute in 2x minus 3 in for y and then solve for x. So x minus 2x minus 3 is equal to 4. Okay, all I did was take out the y and put in 2x minus 3. Now what you need to be careful with is to distribute that negative sign to both terms inside the parentheses. So I'm going to have negative 2x and a positive 3 because remember, a negative multiplied by a negative becomes a positive. So I have x minus 2x plus 3 is equal to 4. Well, now I need to combine my like terms. X minus 2x is a negative x plus 3 is equal to 4. If I subtract 3 from both sides, then this cancels out, and 4 minus 3 is equal to 1. So I have negative x is equal to negative 1. Divide by negative 1, divide by negative 1, and x is equal to negative 1. Okay, so now I have my x value. Now I can take that x value and plug it back in to one of my equations to find my y. So I'm going to plug it into my first equation and do y is equal to 2 times negative 1. Okay, and do minus 3. So 2 times negative 1 is negative 2. Negative 2 minus 3 is equal to negative 5. So that is my y value, negative 5. So my solution here is negative 1, negative 5. Negative 1 is my x, negative 5 is my y. Remember, x before y in the alphabet, x before y as an ordered pair. All right, moving on to question 5. Madison took a test worth 100 points. Okay, so these are the equations that have 100. And they're talking about points. There were 20 questions. Okay, 20 questions on the test. Some questions were worth 2 points, and the other questions were worth 5 points. Again, so we're talking about points and points. So 2 times x or 5y, 5 times y, 2 times x, 5 times y, and then we have to choose the 2 equations from the options below that create a system of equations. Well, here, I don't know what x and y is, but I do know that there are a certain number of questions on the test. And so I'm going to assume that actually x plus y is equal to 20. So this here would be an answer choice because x plus y is equal to 20. Sorry. And 2x plus 5y is also equal to 100 because I made sure that if I'm talking about points, That's the only equation that talks about the value of the questions and the total number of 100 points. This first equation is talking about questions and then uses points as the solution, so we can cross that out. We're not subtracting anything. We're not multiplying anything. And this answer choice right here, again, talks about the number of points, but then gives you the total number of questions on the test. So our best two choices here are these two equations. All right, question 6. Lots and lots of possible errors on question 6. So we want to make sure that we take our time to do this correctly. I'm going to try to color code everything, okay? So 0, -2. If I'm looking at 0, -2, 0, 1, 2, I'm at this point right here, okay? That falls within the dark shaded area, the purple area, so I'm going to check that off. Now let's try pink. 1, 4. So I go here on my x-axis, and then I go up on my y-axis. So I'm at 1, +4, 1, 2, 3, 4. Nope, that does not fall into that purple area, so I'm going to cross it out. Okay, moving on to purple. If I have 0, -4, well, I'm 0 on the x-axis, -4 on the y-axis, I am right here. Well, the problem with that point is falling on the dotted line. If it's falling on the dashed line, dash equals no. So if it's falling on the dashed line like it is right here, it is not a solution. It has to be within the shaded area or on a solid line. So 0, -4 is there to trick you. But just remember, if it's on the dashed line, it is not a point. Okay, now we're going to look at 3, -1. Or sorry, -3, 1, -1, 2, 3, and +1. I'm right here. That is a solution. And -1, 3, -1, 1, 2, oops, almost off the graph. -1, 1, 2, 3. That is also a solution because it's on the solid line. See how that line is solid? Solid, sorry, is equal to yes, it's a solution. Now if I look at these other 2 points, 3 and -1, 1, 2, 3, and -1 is right here, so that is definitely not a solution. So we cross that out. And then I'm almost out of colors. So 1, -3, 1, -3, 1, 2, 3 is right here. That is also not a solution. So 3 correct answers. If you select 4, you'll get the whole question wrong. If you only select 2, you'll get the whole question wrong. All right. Question 7. Stephanie is graphing the following systems of inequalities. So first, let's identify our line. So y is less than or equal to 2x plus 3. So that's this line right here, okay? This is saying y is less than. And if it's less than, then it's going to be below. I'm shading below the line. So if I'm shading below this line, this is where I would be shading. Okay, now let's take a look at this green line. This is y is greater than. If I have a greater than symbol, then I'm going to shade above the line. Above the line. So that would be anything on this side. So where do the two shaded areas overlap? Right here in D. All right. Looking at question 8. Okay. First, we're going to take a look at our red line, which is a dashed line. You're not going to be able to see that, so let me change pens